Denmark and I'm studying mechanical engineering.
My name is Anna. I'm 21 years old. I'm from Czech Republic and study mechanical engineering at Technical University in Liberec.
My name is Steve. I'm 22 years old. I'm from Canada and I'm in automation and robotics.
My name is Emil. I am 22 years old. I'm from Denmark and I study mechanical engineering.
Where we, here in the first week, are going to make the idea generation and make the CAD modeling and make some preparations for the week number 2, where we are going to do all the manufacturing, 3D printing, flight testing and assembling. So we on the Thursday, the second last day, are going to only do the video editing and the handling.
So this is a drone we're working with. It can fly in 2 modes, the rotorcopter way, in which way it will take off like this, and then hover in the air, and it can also do stiff wing flight. Right, so at the moment this functions both as the landing gear for when the drone lands, but also as a stabilizer for when it's doing stiff wing flight. We would like to look into a way to strengthen these, strengthen the landing gear since it's pretty weak, and at the same time optimize its stability as it's flying. We'd like to try and make different designs for this and do a bunch of test flights to figure out which design will give it the most stability as it's flying and at the same time provide proper stability when doing the rotorcopter landing. These 3 designs are the ones that we've come up with. We want to try with a triangle, with one that has a more sharp curve at the back end, and then we want to go with the original design, but with the holes filled out. On top of that, we want to remake the flaps in another material to make them more robust, seeing as they're pretty weak as they are right now. These flaps are one piece, that means they're attached to the body of the drone. So the new ones we'll make in another material will have to attach with hinges.
So I made 3D models of our designs. And we have all 3 designs what we was talking about. So this is the first one, second one and third one. And we also made these parts which should be at the end of the wings for connecting all 3 landing gears.
Right, so now we're gonna make the landing gear for our drone. We're gonna make them using 3 layers of carbon fiber. We've orientated all the fibers in the same direction because we believe that the landing gear will be in full bending.
Thousand years later.
Monday morning, and our flaxseed fiber is done. We've just unpacked it. This is 4 layers of flaxseed, very strong by just using 4 layers. We're going to use these to cut out our third and last design for the end of the wings. It's going to be this one. Got our 3-layer carbon fiber plate out, which we're going to use to make new flaps. We've taken this flap off the drone, only one of them, just to make sure that this can actually be done. These flaps are going to be a little lighter, thinner than these flaps, but that's good because it's going to make up for the increased weight that we're going to add when we put on our new landing gear. Alright, so we've made our first design in glass fiber. These were made using 4 layers of glass fiber. We've made some slight adjustments to the design. We've made these section cuts. This is in order to move the center of mass to the right place. We're very happy with the stability and the strength of it. They're a lot stronger than the originals. They are a lot heavier though, about 4 times as heavy. But we're gonna have to put them on and test them out to see if it's gonna fly. So we finished printing these 3D. These are going to be mounted here instead of the black ones, so that we can put on our different designs for the landing gear. They got these small inserts put into them so that we can screw and unscrew the different sets of landing gear. So we got to pull these off and glue these on instead. They also have our team name imprinted on them, so that's pretty cool. Here we have our new landing gear. This is one of the designs. There are 3. They are screwed on to this 3D printed mount, which we've also made. The fiber direction on the flaps and on the landing gear is multi-directional. So we've managed to stay close to the original weight of the drone, while the flaps are heavier than the original foam ones. The landing gear is actually lighter than the original plastic. So the weight is about the same as when we started working on the drone.
It would be better if we saw the drone flight before we start doing some improvements, so we would know what to actually improve. Because right now it was like that we are trying to improve something and we didn't know how it performed in the air. So
yeah, it would have been. We've definitely learned that it's important to take a good look at the data sheets and really getting comfortable with the manufacturing process before beginning the work and checking the expiration dates of the different materials. We ran into a problem when we were making the carbon plates for our flaps that when we put it in the oven, the tape that we were using would just stop sticking to the plate. So we had to redo all of it, and that's because of the tape we used. That it could have been too old, but it would have been better for us to use the green tape, the tape that we were comfortable with and that we knew worked.
At the beginning of the course, I never heard of the composite material, but now at the end of the course, I'm now able to apply the composite material into our project, and it was so nice to apply 3 different material into our landing gears.
I really enjoyed the space for creativity and for own time management. I really liked that I could try practically things that I only learned about theoretically before. And only one thing I didn't enjoy was the way of evaluation.
So I think the outcome of this course has been really good. I think that the free disposal of time was a good idea. So when we got an idea, we had the opportunity to go do it at the same time. Also, I liked the theory before the practical part, so we just could get answered the questions we had due to any manufacturing part, and then go do it afterwards. So that was a really good idea.
So in this course, I really enjoyed the link between the theoretical part and the practical part. How we've gotten theoretical knowledge and then immediately been able to go to the lab and apply it. What I've really learned about composite materials is the geometrical limitations that it has because of the manufacturing procedure. When working with fiber and matrix, you have to consider how you want to manufacture it because not all shapes are possible.